Hello friends. So let us discuss the second problem from the latest Codeforces round 750, problem named Luntik and Subsequence. Cool. So the problem goes like this, that Luntik came out for a morning stroll and found that an array A of length n. Cool. Now he calculated the sum s of the elements of the array. So now s is the sum of all the elements in the array, and Luntik called a subsequence of an array A nearly full if the sum of the numbers in that sequence is equal to s minus 1. Cool. So now subsequence is just like a sequence of number in which you just delete out some numbers and the remaining sequence is the subsequence. So okay, you just have to delete some numbers and whatever remaining order is that, the subsequence is that number. So you just have to tell that how many subsequence are there such that the total sum of that is equal to s minus 1. Cool. Now what will be your approach? Like, you can pause this video, try to think of this for your own. It's a very simple problem. What you can observe is that you just have to find a subsequence such that the total sum is equal to s minus 1. So first you have to find out the total sum. First you have to calculate the total sum, which is fine. Now the next step is to find out s minus 1. So you have to subtract s, that is equal to 1. So you have to remove 1 from the numbers. Cool. If you remove a 1, then it is fine. Any number apart from 1 is not beneficial for us because removing that number from the subsequence. So you have total numbers, okay? If you remove 1 from that number, then removing that 1 is beneficial because that will like take your total sum decrease by 1, and that's the whole point of decreasing by 1. Cool. So you have to calculate all the ones in your sentence. So cool, that is one observation. So let's say that you have some numbers, that is 2, 3, 1, 1, and some more numbers, that is 0, 0, 1, 0. That is your sequence. Cool. I will also write down 0. I will tell you in a minute. But remember that counting out 1 is important because the total sum for this sequence turns out to be, the total sum is equal to 3, 4, 5, 6, 7, 8 is equal to 8. Cool. Now if you remove 2 from this and keep out the rest of the subsequence as this is a subsequence, then the total sum will become equal to 6. That is not of our concern. We want a total sum equal to 7. So for making a total sum equal to 7, I have to remove any of these ones. If I remove any of these ones and take this as a whole sequence, subsequence, that is 2, 3, 1, 0, 0, 1, 0, then the total sum turns out to be 7, and that is one of the valid answer we can take. So how many ones I have is the options I can delete. Like, I can delete out the first one, or I can delete out the second one. I can delete out this one or this one. So I have 3 options. Okay, so I have 3 subsequence, but whether this is the answer? No. Why? Because removing out 0 is also a better part for us, keeping in mind that how many ones I have also. Cool. Because see, if I remove out 1 from this sequence, so the subsequence will turn out to be this, that is removing out this one will turns out to be, or make out a subsequence like this, that is 2, 3, 1, 0, 0, 1, 0. Cool. The total sum is equal to 7. That is fine. But if I remove 0 from this whole sequence, then it is also better for us. Like, it doesn't make any problem to us. So if I make it like this, 2, 3, 1, 0, 1, 0, or make it like this. So from this I can also make it like this, 2, 3, 1, 0, 0, 1. So removing out zeros in any fashion is beneficial for us. So every 0 I can, like, you can assume that I can either keep it or I cannot keep it. So I have to also keep track of zeros also. And for all the zeros, I can either keep it or not keep it with respect to 1. What I mean by this is, so let's say that I will take the first one and remove it. For that one, if I remove it, how many zeros I have to keep in mind that I can either keep that 0 or do not keep that 0. If I keep that 0 or not keep that 0, these are forming 2 different subsequences. Okay, removing 1 is very helpful. I do not care about all the zeros. If there is no 0, then it is also fine. But if there are zeros, I have to keep in mind of that subsequence also, because like, I can keep it or I cannot keep it. So I have to keep track of ones as well as zeros. So total number of ones, that is equal to, for this talking about, there are 3 ones, and how many zeros are there? There are 3 zeros. So if the number of ones is 1, so the total solution for this answer is 1 into 2 to the power of 0. That is the answer. Why? Because for every one to be removed, I can like do for the zeros, how many subsequences I can form? 2 to the power of zeros, because I can either keep that 0 or do not keep that 0. So for every 0. So that is the solution. You just have to count the total number of zeros and total number of ones, and that's the whole solution for this problem. Let's move on to the code part now to make it more clear. That is a complex problem, as you can see. So total number of ones and total number of zeros, count them out, and the total solution is 1 into 2 to the power of zeros. I can also write down 2 to the power of 0 as 1 left shifted, like 0 number of times. Not 0 number of times, it is actually even the number of zeros I have shifted that number of times to the left, because that is actually, like, this part is actually equal to 2 to the power of 0. Okay, so that's how you can, like, you can do this in bit representation, or you can also write down like power of 2 to the power of 0. That is also fine. Cool. So that's the whole time complexity. For coming on to time complexity for this problem, as you can see that I have done one for loop and then calculating out zeros and ones. So O of n is required to like iterate over and find out number of zeros and ones. Space complexity, as you can see, I have not like stored out the numbers only. So like apart from that, the space complexity turns out to be O of n only to store out the numbers. But apart from that, this calling function, there is no extra space required. Cool. So that's the space complexity and time complexity for this problem. Cool. And if you have understood the logic, then it's good. You can rewatch this video if you have any doubts. Thank you for watching the video. As in, keep coding and bye.